the day you've all been waiting for. All your wildest dreams are coming true.
Is it Willow's favorite? Well, why does it think?
Circles. I didn't mean for it to be that big. Hush. Alright. Guess what? Now that that's big, I feel like I need to draw big again. Okay. Guess what that's called? Center, yes. What's this called? Radius. What's this called? Diameter. What's the relationship between a radius and the diameter of a circle?
Radius is half of the diameter.
Okay. What is this called? Maybe a little bit too big. Okay. So some new those are old definitions. A diameter, by the way, is a type of chord that goes through the center. A new definition, do you guys know what this right here, this piece of pie is called? Probably not. This is new. Oh, I forgot something. What's this angle called? Between these two. We used it yesterday. Central angle. So usually in circles they use, oh gosh, my letters are too big. I'm gonna have to just go down. You guys are going like this. Okay, that is a Greek letter called theta. Looks like an O with a line in the middle. For some reason, whoever decided that's a good letter for central angles. I don't know. Just go with it, okay? So theta is a letter that's often used to represent a central angle. Okay, this piece of pie in here is called a sector. And now this is the only book that I've ever heard use this term. Because you could say this chord is a line segment, right? But this little piece that the chord cuts out, they call this a segment of the circle. So it's kind of a bad definition. But anyway, we're not going to use that as much. I'll write it down here though. The more important thing is the sector of the circle. This is called theta, like theta. What else? Oh, we're not really doing this today, but you guys remember what's this called? Like from there to there, like this thing. Oh, speaking of that, what was the area formula for a regular polygon? Yeah, okay. Like my best circle ever. You guys are take a picture and hang it on my fridge. Okay. Did I forget anything? I think not. All right, let's start with how do you find the circumference? Yeah, let's go blue. How do we find the circumference of a circle? Diameter times pi. That's kind of where pi came from. They figured out it takes pi diameters, like what's pi about equal to? 3.14. It takes pi diameters to go around the circle. So, but what if they give us the radius and not the diameter? 2 times r times pi. Because the diameter is the same thing as twice the radius, right? Okay, that's for circumference, which we are doing a little bit of that. What kind of measurement? What does circumference mean?
The one way around.
Yeah, it's how far around is it? It's kind of like perimeter, but it's on a circle, so it's a rounded edge. It's a one-dimensional measurement, like how many inches or feet or whatever it takes to wrap around. And areas are a two-dimensional measurement. It means how many square whatevers can we fit inside the shape. So how do we find the area of a circle? Pi squared. You just remember that?
No, I wouldn't.
You looked at your book. Cheater. I don't know if I've ever mentioned that this year. Probably not. So we haven't done circle areas yet, but yeah. I don't know if it'll help, but circumference is a one-dimensional measurement. So it's just kind of basic, but areas are two-dimensional measurements. So that's why you have a little exponent of 2 right there, basically. That might help you keep track. Both of these like have a 2, an R, and a pi, but this is a little more to that one. Okay, let's say that the central angle of this sector is 6, and let's say that the radius is 10 inches. Oops, 6. That doesn't make any sense. 60 degrees, that's what I meant. Okay, let's start with how would I find the circumference of this circle? Yeah, radius times 2, so 20 times pi. 20 times pi, whatever that is. Okay, how would I find the area of the circle? That'd be like inches. You guys remember? 10 squared times pi. And what was pi about equal to? 3.14. So 10 squared is 100. What's 100 times 3.14? 314. So it'd be about 314 square inches. Like, this is maybe a little bit too big for an inch. 314 of these things could fit inside there. Okay, but what if I just wanted the sector area, like just this part in here? How could I do it? Okay.
If we know the area, and we know that it's 60 degrees, it'd be like the same, kind of.
What do you mean 60 degrees is the same?
Like that little angle,
Yeah, what about it?
because like the whole thing makes 360 degrees, so you like divide by that.
Oh yeah, so
By
like
the area.
360 divided by 60 to find out how many sectors there are. And then do the area.
Okay, yeah, you guys are on the right track. So if we're using, this little sector uses 60 degrees out of 360. So what fraction of the circle are we actually using just for the sector? 60 out of 360, which that does reduce, right? To like 1/6. So if we just took the area of the circle and then figured out what 1/6 of that is, that would give us the sector area. You guys get it? I'm going to write the formula down here in a second. So that would be like 52.3 roughly. Okay, so the sector area, I'll call it SA, equals, you do the area of the circle, just like that, times what fraction in the circle we're actually using, which is the theta, the central angle, over 360. I'll remind you of this tomorrow. So it's area of a circle times the fraction of the circle, and you get the fraction by using the central angle that goes with the sector, over 360. All right.
Can you go back
just wanted to look at my circle one more time. The masterpiece.
It's like a 2 out of 10.
0 on the test.
It makes Nick Koofman look like a goober.
You got a haircut actually.
Nah, I'm sorry I brought it up. I didn't mean for you to actually talk about it. There it is. Can you see it? Little red circle. Okay. Moving on. Moving on up. Okay, page 335, number 1. Says, what color do we want? Hope's not here to say purple.
Purple. Oh wait, no.
No, orange, orange.
We're gonna carry over like
Do you really want orange?
No.
Orange.
The light
Blue, light blue.
No,
Green.
green.
Blue is green
Higher
actually.
green.
Good blue is
The
green.
one next to that.
Okay, maybe.
Or we can just do like black.
Yeah.
Eyes.
Bruh.
That was my fault.
We should get so lonely.
I should
He was
have.
like the only guy in the class.
Yeah, everyone else is sick.
They're just like all left. They're just plans what they do.
Okay.
It's like they all get expelled.
Number 1 says, find the circumference and area of each circle. So find the circumference and area of the circle. State both the exact value and the decimal approximation to the nearest tenth. What do they mean by exact value? Well, let's find out. Okay. No, there's no square roots on circles. Normally. Not normally, I should say. Okay, on number 1 it just says 6 inches right there. 6 inches, this would be the what? Shh. 6 inches. 6 inches is the what? The radius. So how do I find the circumference?
6 times 2.
Hmm?
6 times 2.
Radius times 2 times pi. So it's just
Oh, this is
12 pi inches. Okay, that is the exact answer. Because once you turn pi is like an infinite, non-repeating decimal. So there's no way of writing an exact answer if you actually multiply by pi. But they said we're also supposed to give the decimal approximation rounded to the 10th place. So what is, you actually have to use your calculator on that. If you use 3.14 and not the pi button, your answer might be slightly off from the book's answer. I'm not going to count it wrong though. You can use 3.14, but you might get like 2.17 instead of 2.16 or something like that. But anyway, you just got to be close. So what is this equal to? Anybody plug it in?
I'm trying to find it.
It's usually, you got to look above the button usually. There's not a pi button, you have to like hit shift something. It's,
Oh,
pi is
there.
about 3.14.
I found it. Okay. It just says 12.
It
Oh,
should
never mind.
be,
It says 37.699.
okay, we're rounding to the 10th place, so it's 37.7 inches. Okay, and then how do we find the area of a circle? You guys remember that one? Somebody besides Isa.
Oh,
Pi r squared. Maybe Isa forgot too. Pi r squared. So we got to square the radius. What was the radius? 6. That is not the diameter, right? It was just halfway. So anyway, 6 squared is 36 times pi. And this would be inches squared because it's an area. What does that come out to? Okay, what is different on number 2? They have the 11 is the diameter, not the radius. So if you need to find the what would the radius be on 2? 5.5. Half of 11. Okay. Number 3, 9 halves squared of 3 is the same thing as 9 halves times square root of 3, which is like 9 square root of 3 over 2. Might be an easier way to write it. 9 square root of 3 over 2. So to find the circumference, we need to do 2 times the radius. You guys know how to do this times 2 without a calculator? It's really quick. You guys remember this trick, right? From middle school? Or maybe grade school even. So the 2's cancel out, so that would be like the diameter of the circle times pi. What should I do with the pi? Okay, why would I not put the pi right here? Because it looks like it might be under the square root. So really what you want to do is write 9 pi square root of 3. Put it right there. And number 3 is feet. And then you plug that in the calculator. 9 pi squared root of 3 is 49.0. And then the area, pi r squared. So, it's a little bit hard to square this thing, but basically you just square everything in there. So 9 squared is 81. Square root of 3 squared is 3. And 2 squared is 4. So it's like 243 over 4. Times pi, of course. Okay, that's the exact answer. They might have put pi up top. I don't know where they put it. Doesn't really matter, but yeah, they put it on top. Okay, which is about 190.9. Can't put it all in the same. Okay. All right. Now we're going to go around the room on these problems. It's like fill in the blank. Okay. So, does anybody want to volunteer to start? I'll just pick somebody. All right, Willow. On number 5, if the diameter is 4, what is the radius? 2. So you can just put like 2 since it's the first answer, comma. All right, Shelby, if the diameter is 4, how do you find the circumference? 4 times pi. So you just put 4 pi. We're not putting decimals, just put 4 pi for your second answer. And Anya, if the diameter is 4, the radius is 2, remember how we found the area?
Pi times r squared.
Yes. So what would r squared be on this one?
4.
Yes. 2 squared is 4, so it'd be 4 pi. You don't have to worry about labeling it like units and units squared. Just you can skip that part. Okay. Isa on 7, they start by giving us the area. 0.04 pi. So if 0.04 pi is the area, how do we find the radius? Well, the area is radius squared times pi. So the radius squared must be 0.04, right? So how do I find just the R? What's the opposite of squaring? Square root. Yes. You are correct. Anybody think they might know what that is without calculating? Maybe not. Somebody in another class said 0.02. 0.02 times 0.02 is 4 with 4 decimal places. So it's 0.0004. It's 4 10,000ths. So really what it is just 0.2. Because 0.2 times 0.2 is 4 with 2 decimal places. Anyway, that's the radius. Olivia, if that's the radius, what's the diameter? This is the radius. What's the diameter? How do you go from radius to diameter?
Times 2.
Yeah. Remember the radius just goes halfway. Yeah. So what will that be then?
It's stressing me out.
0.2 times 2. 0.4. Okay, and then, okay, Anna, if the diameter is 0.4, what would the circumference be? 0.4 pi, yes. And Shannon, if the radius is, wait, we already have the area, never mind. Forget that.
Can you go up? Just a smidgen. Thank you. Actually gets what she needs.
All right, Caden, on number 9. So they give us the circumference on 9 is 30 pi. If the circumference is 30 pi, what does that tell us, Caden?
The diameter is probably 30.
The diameter has to be 30. Because it's just diameter times pi equals circumference. So the diameter must be 30. Now that's 30 is actually the second answer, right? So you might want to put that a little to the side. If the diameter is 30, what's the radius? 15. So put 15 comma 30. And then the area, Willow, how do we find the area again?
Pi r squared.
R squared. So the radius we just said was 15. I don't suppose anybody knows what 15 squared is, do they?
Here, 125.
No. 225. So it's just 225 pi. All right. Number 11, fun in the sun. Why don't you guys read 11 on your own, see if you can make any sense of that, and then we'll talk about how to do it. Number 12 is fairly similar. It's kind of a little ish. Do you know how to read that number? Okay, these are the ones, right? These are the thousands, millions, billions, trillion. So 3,760,000,000,000. So yeah, you guys know we had like 20 some trillion in debt.
That's a lot of money.
That's a lot of money. It's more money than we,
You could solve a lot of things with that kind of money.
it's more money than, we're spending more money than we're making, our country is, so. We might go bankrupt when you guys are older. Good luck with that. All right. Because I'll be dead, It'll be your problem.
Yeah, what if you live to be 300?
Yeah.
I wouldn't bet on me making it to next year. Just kidding. Okay.
Come on, we gotta finish that high
Are
school.
you?
Okay. Determine the central angle measure for each sector and the amount of federal spending in each category. So we're supposed to figure out how many degrees the angle is for the category and also how much money that represents, how much money is in each category. Okay, so on welfare, which color is welfare? Yeah, it might be brown, possibly orange brown. So that's 10%. So how many degrees would the central angle be? That's the first question. No, we don't do that. Well, any ideas?
360,
10% of 360. You guys remember doing this in Algebra 1? How do you find 10% of 360 degrees?
Do you do like
10% turns into what? 0.10, or you could say 0.1. Of means, anybody know what it is without a calculator? 10% is like 1/10, yeah. It just comes out as 36. Okay, that's how many degrees the little piece of pie has, the central angle. But they also want how much money are we spending. So the money we're spending would be 10% of the 3 trillion thing. 3 trillion, 760 billion. Thousands, ones. Okay, but here's the thing. They say in the directions that we're supposed to round to 1/10 of a billion, I think. So what I'm going to do, you don't need to write all that now, is just cut off the millions. And I just need to know that this is like the billions place. And this would be like the 1/10 of a billions. Sometimes they'll say the hotel costs like 4.5 billion to build or something like that. But anyways, we can just multiply by this. We just need to know this is like trillions and billions. But we're supposed to put our answer in billions. When you multiply by 10, you guys know what that one's going to be? It's going to be 376. Like the decimal just moves over. So it's 376, but it's not $376, it's $376 billion. With a B. That's how much money we spent on welfare in the year 2015.
Well, that's a fair amount.
Can I have that, please? Get out.
That's a lot of money. Okay, defense. How much did we spend on defense? 22%. So we need 22% of 360 degrees for the angle, and we need 22% of 3,760. But I just need to keep in mind this is actually billions, not $3,760. So this one comes out as 827.2 billion. C is healthcare. So that is, what color is that? Yellowish. So that's 27. Healthcare is the biggest piece of pie, it's 27%. That's more than a fourth of our budget. So we need 27% of 360 degrees, and we need 27% of 3760. Getting warm again. No, this one's kind of weird. What is it, 1,015.2 billion? I don't think anybody would ever say it like that, but whatever. 1,000 billion is actually a trillion, so that's kind of a weird way to say it. Over a trillion. And this was back in 2015, so inflation has gone up a lot since then. D is education. Black, 4%. How do I write 4% as a decimal? Anyway, whatever that is. Let you guys finish it. We will just stop here today. It's Wednesday. Let you guys try. We'll finish it tomorrow, probably. So your homework, or try to get it done in class at least, is 1 through 2 through 12.